In this video, we'll be looking at the arithmetics of convergent series, and basically we are just going to confirm what you have probably already guessed, that if we add two convergent series, we'll get a convergent series, and if we multiply a convergent series by a number, you will also get a convergent series. And their sums will behave nicely with respect to addition or multiplication by a number. So our proposition is just formulating this. So assume that the sum of ak with k going from 1 to infinity and the sum of bk with k going from 1 to infinity are convergent series, and alpha and beta are some real numbers that are arbitrary. Okay, then the series that we obtain by multiplying the terms in the series ak by alpha and the terms in bk by beta, and adding these products up, is also convergent. And if the sum of ak is denoted by capital A and the sum of bk is denoted by capital B, then this sum of alpha times ak plus beta times bk is going to be equal to alpha times A plus beta times B. Okay, so there's nothing surprising here, and it all can be proved using the definition. So the nth partial sum of this series that we have obtained by taking a linear combination of the series ak and bk is convergent, converges to alpha times A plus beta times B by the arithmetics of limits. Okay, so this is something we have seen when we've been looking at limits and their behavior with respect to addition and multiplication and so on. So this is just the same thing applied to the sequence of partial sums. Okay, so this concludes the proof, and I would like you to consider the following example just to test your understanding. So I want you to calculate the following infinite series. I want you to calculate 7 divided by 3 to the power k minus 1 over 5 to the power k, with k going from 0 to infinity. So add these terms up, and I want you to calculate the result. Pause the video and input your answer in the box below. Okay, so I hope you have paused it. Basically what you have to notice is that what we have here is a linear combination, such a combination of two geometric series, one with a quotient, a number q that is 1/3, and the other one is with a quotient that is 1/5. So basically what you can do is to take these things apart to say that this is 7 times 1/3 to the power k going from 0 to infinity, minus 1/5 to the power k with k going from 0 to infinity, and then apply the geometric series formula for each of these terms. So it's 7 times 1 divided by 1 minus 1/3 minus 1 divided by 1 minus 1/5. Okay, so here we have 2/3 in the denominator, which is 3 halves if we flip it around. So 7 times 3 halves minus, here we have 4/5 in the denominator, which is, if we divide it by 1, it's 5/4. So what we really have is 21 over 2, which is 42 over 8 over 4, and then we have 5 over 4 minus 5 over 4, so that is 37. That is supposed to be 37 over 4, yes. Okay, so this is the number we got. Well, if you want to express it in decimal expansion, you get 9.25. Okay, I hope you got this right, and I'll see you in the next one.